to be speaking to you all this morning. I'll be chatting for about 20 minutes, and I'm going to focus on our system as it stands as a whole, but focusing within technology within that. Next slide, please. Thank you. I'll have a look at some of the technological challenges as we redesign our flying training system. And then I'll focus a little bit at the end on how we're doing within the system design itself to address the challenges that we've got. Next slide, please. So on slide 2 here, you can see this is just a very general overview of the structure. And I've covered this at previous conferences before, so I'll go over this pretty quickly. The way we address flying training in the UK, first of all, it's a joint organisation with industry. So as you can see, it's a very expensive program, but it's spread out over a 25-year contract with industry to give us that continuance right the way through a couple of decades worth of consolidated service to defence. We do that through a consortium which is known as Ascent Flying Training. That's a consortium of Lockheed Martin and Babcock. And also, of course, nested within 22 Group. Now, while that's an RAF training group, it's a joint organisation which is responsible for the training of all military aircrew across all 3 services here. Next slide, please. Just looking at some of the key challenges that are likely to face us over the coming period. So I'm just going to try and expand my slides so I can see them a little bit better here. Okay, first of all, when we introduced the military flying training system, we did so with a combination of specifically military designed aircraft and also commercial off-the-shelf aircraft. And I'll talk a bit more in specifics on those later on. But that gave us some considerable challenges in adapting those aircraft to ensure that they were fit for purpose for the military area. Again, more on that later, but it's just something to MB when you do go down the sort of the non-specific military designed route for your equipment. It's certainly given us some challenges in the past. But of course, the greatest challenge today that faces us is one of capacity, supply and demand. From a COVID perspective, this hasn't been all negative from the military perspective. In fact, it's been generally positive in that people have stopped leaving. So our retention challenges over the previous decades have essentially evaporated over that 1 year. And also, of course, with the very perilous state of the airline industry, certainly within Europe, we've attracted a lot of ex-military pilots back into the military. Now, we're all very aware, of course, that when we emerge from the pandemic, and the sooner the better, we're obviously expecting that a lot of those pilots may wish to return to their previous employment with the airlines. But as yet, that's uncertain. So we've got quite a lot of unknowns as we try and navigate our way through the coming years to really understand what it is we need to supply. So at the moment, we're in an enviable position whereby our front line is actually full. So, and I'm speaking right across all streams of multi-engine, rotary and fast jet. Now, of course, that's great in one way, but in another way, it gives me a huge challenge because, of course, the flying training system is designed for a certain outflow from the front line, which, of course, at the moment is not there. So right now, my principal challenge actually within the UK flying training system is what do we do with the capacity of it, knowing that the capacity today is more than what's required. However, we've all seen the boom and bust system and cycle of flying training, and that's one of the biggest challenges that I think faces us today. And I think with the advent of technology and the faster changing pace of society in general, it's probably even more likely that that cycle of boom and bust may even accelerate, which means the management of flying training becomes ever more challenging. And I'll address how I plan to crack that challenge as we go through the next few years and what we do with our own capacity within UK MFTS. As things stand at the moment, though, our system is designed for around about, I'm just focusing on the fast jet for a moment, around about 50 pilots a year out of our system into the Royal Navy and the Royal Air Force front line. Of course, we're looking to bring a whole bunch of technology in as well, which is going to help us dramatically as we understand how to make our system more flexible and more easily able to adapt to the changing external environment, whilst, of course, we are looking how to adapt our internal environment according to the situation within the military itself. Next slide, please. So when we look at, sorry, could you just go back? We should be on adapting COTS. Thank you. Thank you. If we look at commercial off-the-shelf, I know a lot of air forces are into this technology right across the globe as we stand. We're addressing this from several angles, actually. From a COTS perspective, of course, there is passive training and active training. From a passive training perspective, that's really about what I've got on the title there, the sort of 360-degree high-definition video recording of everything that a student could possibly experience on the ground through looking through a set of goggles on 360 videos of instructional sorties from the air. So we're looking to record essentially our entire syllabi collection across all streams of flying training to build up a comprehensive database that enables a student to rehearse what he's going to go and learn in the air as many times as he wants. And that, of course, can be out of the work environment. It can be before he even starts his flying training course, if he so chooses, if he's got the time, to make sure that he's as well prepared as possible for the events before they occur. But that's only passive. Then, of course, we've got the active learning, which is really where the more hands-on VR capabilities that are coming online come to the fore. We're doing that starting off actually on our Texan aircraft, and I'll cover our whole flying training setup later on as to how all the aircraft fit together. But I just wanted to focus on technology initially. So we're starting that on our Texan aircraft, whereby we've just spent 6 months trialing the utility of VR systems. And what we've decided to do in the RAF and our joint system is go for high-end VR to generate as immersive an environment as we possibly can. And because there's a choice, of course, you can go cheap and cheerful. Now, of course, all of this technology is reasonably inexpensive in comparison to full motion simulators, but still there's a tremendous variance between your cheap and cheerful and actually going for the high-end VR technology that may have haptic feedback, force feedback, as good a goggles as are on the market today. And that's where we've decided to pitch our technology to ensure that that is as immersive as we can get. So what we've actually done then, if you go to the next slide, please, is what we've tried to do through understanding how this immersive technology really contributes to a better flying training system, is to run a trial for that 6-month period that compares this technology directly with the FMS. And so what we've been able to do is to do scientifically controlled trials whereby we've had 2 control groups. We've had up to 20 students going through a VR system and a similar number being assessed through the FMS in certain learning disciplines, be it flying circuits, aerobatics, instrument flying, that sort of thing. And then what we've done, once we've assessed those 2 things, we then take both of those groups and we put them all into the full mission simulator to see how they get on. And of course, you have to put various tolerances in there due to familiarity with systems, et cetera, et cetera. And the results we've seen so far, although it's still quite early days, have been absolutely fascinating. And whilst, as you would expect, those going into the FMS are slightly more able to perform to a higher standard in the FMS, not only due to familiarity, but other reasons too. And our experience that we've seen now through these trials, in fact, those going through the VR are only just slightly behind, to such a point that it's almost indistinguishable. And that's really interesting for us as we try to now understand the difference between what that overall synthetic solution gives you versus what students achieve in the air. So this has been a 6-month journey that now puts us on the springboard to bring these systems into mainstream. And I'll be expanding this trial now out from Texan into Hawk and back into our elementary flying trainer as well, the prefect. And we're going to be doing that over the next year so that we can bake this technology into formal syllabus activity, as well as informal learning for the students to run at their own pace. Okay, if I could have the next slide, please. Of course, none of this is truly useful unless you understand where you've been so that you can manage properly where you're going to go. From a data exploitation perspective, we've got a long way to go here. So we're just at that starting point of trying to understand what it is we need to measure and how important that data is. So an example might be from the trials that we've just been performing, that we have eye tracking software, as you might expect, and just to look at how a student is moving his head, not just certainly in instrument flying, where it's invaluable for teaching things like an instrument scan, but also, look out in the circuit, or just look out in general, where you can map exactly where the student is looking, compare that to where he's looking in the simulator, and then you can use that as a descriptive teaching method for ensuring that he takes the correct lessons into the air. But unless you use that data clever, in a smart manner, there is absolutely no question that you're going to be missing half the benefits of being able to measure it to begin with. So we're going to spend a lot of time trying to understand that. And of course, that will eventually lead into the more development of more of an AI factored learning experience as they go through this type of immersion. Right from the start, we're looking to understand how we create that database of evidence. That's key as well. Obviously, when it comes to procurement decisions, we need to ensure that we have a proper foundation for what it is that we're looking to achieve. And that is only going from strength to strength as we go. But this is not easy. I think when I look at the last 6 months worth of activity, and indeed all of our exploration before then, quite honestly, the equipment is the easy bit. And it's all too easy to be seduced by it. It's very user-friendly, it's quite intuitive, the students love using it. But the issue here is unless you think through all the steps of data exploitation, you will miss the learning points. And of course, you'll only get a small fraction out of the capabilities of this system, these types of systems that the future is likely to offer. So I can't stress enough how important that is, but that requires investment. That requires a lot of smart thinking and smart contracts into most areas that most of us won't understand. So we need a lot of assistance with that from industry to help us shape the use of data in this really important interface between VR, the more traditional synthetics, and the flying environment itself. Next slide, please. I've covered this, so I'm just going to glance over this in very general terms here. The commercial off-the-shelf aircraft that we've got in our flying training system are the ones that are not sort of shaded out there, which is on the top row there. You've got the prefect elementary trainer, the Embraer Phenom, which is our multi-engine trainer, and down below we've got our helicopter suite, which are Airbus 135s and 145s. One bigger than the other to allow for crewman training down the back end, which is all part of the directorate's activity there. So I just mentioned that simply to show that all of those aircraft we have brought into service over the last 10 years. That has given us a tremendous challenge. So as all air forces around the world are looking to understand how to restructure flying training for the future, this challenge nearly broke us actually. And whilst we're through it now, and all of these systems are now fully in service and fully operational, to bring them all in at a very, very similar time has put tremendous strain on our system that literally has taken 5 years to iron out. However, we are there now, and our capacity is increasing up to the levels that was designed through the contract, so that we are now in a position where we can really look to the future, and instead of focusing on these aircraft to the extent that we have, we can now move much more into the synthetic area to understand how to improve our output per given flying hour. Next slide, please. So when we look at how we have managed to increase production within the UK MFTS, I've spoken about the CV19 and how actually that's been quite positive in a perverse way for us. In the UK here, we've also had an integrated defence review go through this year, and that has generally produced some down arrows for us across the aviation sector. So we're right at that time that you can see we've got that sort of double whammy of being retention positive, people returning into the service, and also a slightly reduced demand on the front line too. So that has all resulted in this ability for the organization to overperform, not necessarily a good thing, but it does give us capacity, which means that we now have options. Options to the extent that over probably the next couple of years, I'm likely to be training more aircrew than I have slots for. So we're going to try and see how we can use them most effectively across the globe. But it also gives us, so those are just for the people already within the system. But just as importantly, I therefore have extra capacity within the system to attract training from overseas as well. So we'll be looking to see how we can do that to ensure that the system remains at capacity. Now, as I mentioned at the start there, the reason that's so important is because, as we know, the boom and bust cycle of the flying training system is such that whilst you can contract overnight, actually expanding it takes years. And as we found from our last expansion, which is through our strategic review of 2015, it took us essentially 3 to 4 years to expand the system, buy more aircraft, train the instructors, etc. So what we're doing this time around is we're actually going to maintain the capacity within UK and FTS, see if we can, again, attract that external customer within it, so that in the years to come, when again the demand signal increases, we already retain that system's capacity, so I can simply turn on the tap very, very quickly. And so, for example, we would allow international students to move through, replace with sovereign students, and then we would have addressed the system. You can only do that, however, if your system itself is short enough. So if I could just go to the next slide, please. So what we've done as far as system design is concerned is we've taken a system that was generally fairly legacy by design, in as much that whilst we've had new equipment, it pretty much replicated what we did in the 80s, 90s, noughties, and gave us a similar looking system, a 3 aircraft sequential system that took many years to get through. And if you end up with any sort of back holding or sort of backlog of students, you can get into a real logjam of the system there due to its complexity. So what we've done now, and we're just in the sort of final stages of designing this before we implement over the coming year, is to give students different pathways through flying training so that they can get to the front line in super quick time. The system by design is going to have students from their officer training to their frontline OCU inside 2 years. And in fact, for the rotary aircrew, it'll be about 1.5 years, and not too dissimilar for multi-engine aircrew, slightly longer for the fast jet sphere. And the way we're going to address that is by downloading far more training into university for the university graduates. So, for example, those who are going to be good enough to go fast jet will go straight from university to the Texan. They'll miss out prefect flying altogether. They'll do about 9 months on the Texan before going straight to the Hawk. Similarly, other students who start off their flying training on prefect are then going to do an extended course on prefect before going straight to the Hawk. And now, obviously, there's some risk in there. We're going to assess exactly how we do that, but we've already completed the trials. We know the system works, albeit in small numbers of students, and they are coping very well on Hawk today. So we think we have a system there that actually is a 2 aircraft system rather than 3. And it also means that I can therefore reduce the overall throughput on both prefect and Texan, which gives me an ability to play tunes between those aircraft types according to where my capacity is at that time. So what this introduces is, yes, some additional complexity into the system, but it also means that I can be very much more reactive according to where that capacity is. And then finally on rotary, for the first time, we're moving away from all rotary aircrew going through fixed wing training to start with. They're now going to be going to rotary training right from the start, as soon as they've had a brief streaming on a basic aircraft, which will be sort of 10 to 15 hours or so on a fixed wing piston trainer. They'll then be going straight to rotary training for the rest of their phase 2 training before going to the front line. So quite a different approach there. That'll be about 1.5 years. Next slide, please. So just finishing off, and I've covered most of these points already. Retention is obviously going to be the theme over the coming days. I think that from my perspective, this is all about creating a future for aircrew that gets into the front line as fast as possible that means that they've got as much give back to the front line, which is obviously what they're in the services for, as we can give them. The plans at the moment look like we're going to get around about 2 more years use out of them on the front line, which will hopefully, essentially around about another operational tour's worth, which really will change the dynamic of the experience on the front line as we wind the clock forward about another 5 years or so. So that not only addresses retention issues, but it also addresses some of the dilution issues that we have on the front line today. So we'll be able to get them there faster and therefore keep them there for longer. Of course, we still need to bring some of those individuals back into training at some point. So that's pretty much where I want to go with today. So that's just a very brief introduction of where we are within the UK flying training system at the moment. We've got about 10 minutes or so. I'd like to open the floor now to any questions. Thank you.
Jamie, thanks very much. Great presentation, great coverage. We've had a few questions coming in. I think one of the sort of there's themes developing, and I think one theme is this use some of the immersive virtual reality technologies that we're seeing. Given the challenges you raised over the introduction of so many different types at the same time, clearly, trying to adapt to these new technologies is another challenge, I'm sure, that's facing the group and the units. How do you balance, the rapid advance in this technologies and what you can do with it in training against the more longer term nature of some of the procurement plans for the aircraft themselves? Has that been a source of tension, or is it one that you can easily get over?
It's not a source of tension, but that doesn't mean it's straightforward. The answer here is, obviously we're familiar with spiral development. Clearly with COTS solutions, you can do that. I'm not talking about the aircraft now, but about the technology. Generally, the equipment itself, the hardware is COTS, but of course the hard part comes in the software, which of course you have to have the right flight modeling to ensure that you're not learning the wrong lessons. And then you have to understand how you're going to create the learning experience for the students that's applicable. And that's where the rubber hits the road on this technology. Otherwise, it just becomes a game that will have limited utility. So the key here, therefore, is an understanding how much you think you have to spend on it, but then how quickly you will need to iteratively develop what you have. So, for example, we think the equipment that we're bringing in at the moment, so as I said before, it's very, very high end, but it's probably only got a shelf life of a couple of years before something will have come on that really is a quantum shift again. And again, as we look at this exponential increase in the technology's ability to become ever more immersive, we need to think really carefully about how high end we can afford to be, knowing that we need to replace. So the strategy that I'm looking to employ here is, yes, we are going high end initially, but from when I look to the investment strategy, I'm looking in sort of 2 to 3 year cycles, and whereby every 2 to 3 years, the old equipment I will move into other areas, such as into university air squadrons or into areas where they don't need such high fidelity. And that way, hopefully, we'll be able to stay on the front edge of that and keep it useful. There's absolutely no question that the golden nugget here is how immersive is the experience. And the more immersive it is, the more students will want to do it, and therefore the faster they'll learn. So this is really all about creating an experience that is desirable for them, not the usual sort of sweat box of an FMS where it's all very regimented. They only get in there probably every couple of weeks, whatever it happens to be, unless it's a certain phase. And it's a very, very different environment. This one is going to be far more student-led, whereby they are able to dictate and actually show us a lot of the things that we haven't been considering, because of course they're going to be the experts at this. And a lot of the students coming through at the moment have already bought their own systems, so they're very, very up to speed with the technology, and they're going to help us shape this as we go. So I think from a procurement perspective, it's really going to be a question of understanding boundaries, understanding refresh rate, but most importantly, not forgetting what lies beneath it, which of course is that whole data analytics piece. And without that, which is going to be considerable and actually is probably going to be a bigger portion of the procurement challenge in comparison to the equipment itself. But that, of course, is likely to be a longer term contract that will sit underneath the equipment that will drop in phases as we go through the next decade.
Yeah, absolutely. And one of the other sort of, follow-ons from that was, do you see that mostly in the sort of, basic and up to, advanced training, or do you see it all the way through the spectrum of training from basic all the way through advanced to the front line?
Yeah, I see it right the way through. Of course, the challenge that you have as you go further right, you're getting into classification. So it's easy enough in what we call phase 2 flying training because it's generally unclassified. Now, there are elements that are, but generally what you keep on the ground, certainly in the VR environment, is going to be unclassified. So we've got tremendous advantage there. And the other advantage, of course, is that you can join string between bases. What I'm looking to do, for example, is to link up our air traffic school, which usefully also comes underneath my directorate, link the air traffic school in with our flying training schools so that you can actually have live air traffic feed coming into the same environment that the students are learning to fly in. But you can do that right through flying training. And again, you can wind it all the way back to university as well. Clearly, the front line is doing the same thing, but they will be obviously constrained to an extent by the classification issue. It just makes it more difficult for them, but by no means impossible. I think it's just a longer road.
Yeah, cool. And one of the other threads was about, the age-old problem of streaming and selection, streaming people, if you're looking at rotary pilots, directly onto rotary, is there the risk of streaming too early and risk on losing out someone that's a late developer and could have made it, potentially through to, as you said, one of the fighter pilot streams? This is something we seem to go around sort of every 5 years or so.
We do. It's a real risk, and we haven't got to the bottom of it yet, to be fair. So, for example, we are probably going to be streaming at university, and that's a big challenge because that depends on, what is the currency that the student has, how hard is their degree. So there's a lot to consider if you are going to stream at such an early point. So there's no question in my mind that we will be increasing the risk in flying training of student failure to a point. But the key here is that acceptable? So at the moment, we have generally about a 10% washout at each stage. Now, if that were to go up a bit, but I've managed to shorten the system, say by 40%, that might be entirely tolerable. So we're now just trying to understand, it's slightly easier in the RAF than it is in the other services because we've got such a broader spectrum of aircraft types. So if somebody does get unstuck at any stage, they can go into another stream. It's not quite so straightforward in the other services. So we just need to make sure we think through how we are adjusting that risk appetite. But you're absolutely correct. It certainly will go up to an extent. But of course, again, technology may help us there in understanding better ways of assessing people. All the psychometrics that we look at through our Officer and Aircrew Selection Centre is going to be modifying as well, as we understand how to use these techniques far, far more intuitively to get a much, much better understanding of the student's raw capability at an earlier stage of their flying experience. So I'm hopeful that if you mash those two things together, we're going to be okay. But it's still early days. It feels a bit experimental at the moment, but I think the risks are diminishing the further we get down that thought process as to how we'll mitigate that. But it's a very good point, and it is a concern.
Yeah, a huge challenge, I guess. And I guess the other challenge is, who is doing the assessment at that pre-streaming stage on the UASs et al. And it's having the ability to stream people and separate, who you want to take forward in those various streams.
Yeah, that's true. Now we will use our central flying school to do that. Obviously, CFS, it has the purview right across flying training as far as maintenance of standards is concerned, but they are also used as my lead organization for innovation as well. So they will have that understanding as to what we're looking at university to try to ensure we get that right. So at least we'll have a common baseline there. I'm not expecting the university air squadrons to be able to stream because they won't have the backgrounds to do that. So they'll need a lot of assistance with that. That's all yet to be worked through as we understand how we're going to introduce that part of the pipeline, which is likely to be next year.
Yeah. And the last one really relates to, availability of people coming into the system. Clearly, with the impact of COVID on the airline industry, we've probably got a number of applicants. As the airline industry opens up again and there are opportunities in the civilian industry, do you think that's going to impact on the input stream? And can we afford to be, selective, or have we got to take more time?
I think we can. We've really not had an issue because defence is frankly not that large. We've really not had an issue in getting the quota for aircrew. In fact, we have found that when we turn down the aircrew pipeline too much, it affects other branches through association. They see recruitment and aircrew going down. They assume it's the same for other branches too. So we've got to be really careful there. And that's been a lesson learned over the last decades. However, we are very comfortable with the recruitment at the moment for aircrew across all the services, and we certainly don't have any holes in that at the moment. So even in an upturn to the airlines, you're talking generally about a slightly different demographic. So I'm not seeing much risk in that particular area.
Excellent. Jamie, that was great. Many thanks for your time this morning and your presentation and your obviously very frank answers to some of the questions. A lot of interest on the question forum coming through, but in the interest of time, we'll draw it to a close there. We're lucky enough to have you back later on for one of the panel sessions, so we look forward to your inputs to that. But again, for everyone here, thanks very much, and we'll see you later.
Okay, thank you very much. Look forward to the rest of the conference. Thank you.
All right, great. Thanks, Jim.